Okay, what are NumPy arrays? NumPy arrays, which are also called ND array, are arrays which have fixed size at the creation. As you know, Python lists can grow in time. You can create an empty list, or you can create a list with some number of items, and then you can add new items. You can delete items from a list. But NumPy, and also in a list, you can put data of different types. You can put integers, strings, floats, etc. Different types of data in the same list. But NumPy arrays are not like that. NumPy arrays are, when they are created, they are, first of all, have fixed size, and then all the elements must be of the same data type. All the elements must be either an integer or a float number. You can probably create NumPy arrays with strings, but I'm not sure about that. But anyway, NumPy arrays are probably, since it is numerical Python, abbreviation of numerical Python, you can create arrays of integers or arrays of floats, but not a mixture of these, okay? When you change the size of an ND array, in reality, it creates a new array with the new size, and it deletes the previous array, okay? So once an array is, a NumPy array is created, its size doesn't change. The elements of NumPy arrays must be all of the same data type, and they facilitate advanced mathematical and other types of operations on data. What are the NumPy data types? There are several data types. We can create a bool, a NumPy array containing Boolean values, integers, int8, blah, blah. I will not spend much time about this. As you see, there are different types of integers and different types of float numbers, okay? And you can also create a NumPy array containing complex numbers. In order to use NumPy arrays, you have to import NumPy package to your program. So when we write a NumPy array program, let's go to the top of this program. Here I have a statement which contains import NumPy as NP. Usually NP abbreviation is used for NumPy arrays, and that's why I also added this as NP. Otherwise, instead of here, for example, I just write NP. If I don't put this as NP, if I only write import NumPy, what I would do here, I would have to type NumPy, okay? Instead of typing NumPy every time, what I do, I just type NP, which is an abbreviation of NumPy. So after importing NumPy to our program, we can now create NumPy arrays and use them. There are several methods. There are lots of NumPy methods. I will just show you some of them, the most important ones, the most frequently used ones. First of all, there is a method called array, which is a constructor which is used to create a NumPy array. You can create a NumPy array either from a list, a Python list, or a Python tuple, or you can, by using some other methods of NumPy arrays, you can create an array. Let's see our first examples. We have zeros here. Okay, what I will do, I will just start to show you array. Yeah, here I have NP array. Here I have a list, okay, on line 75, I'm creating a list from 2 to 33. Of course, as you know, in range function, it starts from the first one, but the second parameter is exclusive. And each time here in this range function call, we are increasing the value by 2. So it will start with 2 and it will generate, let's put here a comment, which will show 2 and 4 and then 6, blah, 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 up to 32. Why up to 32? Because 33 is exclusive. So as long as it is from 2 to less than 33, it will be valid. So it will create a list of these numbers. Okay. So this statement creates a list. Here we have np.array, which accepts a list as parameter, and this creates an np array, a NumPy array. Here we have np array convert this to tuple blah blah. Let's run this and see where is the output. Array operation. We have to go top. Here, convert list or tuple to NumPy array. What I will do, I will also print the list. Okay, print ls2, which is our list here. Okay, here we have a list. From this list, ls2, we are creating a NumPy array using the array method. Let's run this again. Here we have our, where is it? Here I have my np array. Okay. Here, as you see, the first one is the list, which contains values. As you see, when I print a list in Python, it starts with a square brackets and ends with the square brackets, and all the elements of a list are written separated with a comma between them. When I print a NumPy array, as you see, there is no comma printed. It is just the values are printed with some space between them. Why there is extra spaces here? Because here there are 2-digit numbers. What Python does when it prints a NumPy array, it looks to the numbers here. Whichever is the longest, it fits the smaller number to the same spaces on the screen. So since there are 2-digit numbers here, it prints 1 space and 2, and then once after a space, of course, and not natural, there is a space between each of them. There's a space and 4, space and 6, space and 8, and then there is no need for extra space. There's already a space after 2 and 4, etc. But there's another space with 8 or another space with 6, etc. So NumPy array just writes the values according to the highest number of digits. Okay, let's write another one. Let's put here. I will just make another example. Okay, and I will show it later on. So using the array method of NumPy arrays, we can create a NumPy array from a list. Okay, we take a list as parameter, and np array creates a NumPy array from that list. Of course, the list may contain duplicates, and the same duplicates will exist in the NumPy array. A NumPy array naturally may contain duplicates, and what else? The number of elements will be equal to the number of elements in the list, etc. What is the next? For next function, arange. There is a NumPy method called arange, which is similar to range function that we have been using for a long time. But there are some advantages with arange. First of all, with arange, you can also use float numbers. Okay. Normally, range function gets only integer values. It can be increasing numbers or decreasing numbers, but you only process integers with range function. With arange function, you can either have integers or float numbers. Let's see some of these. Here I have an example on line. What I will do, okay, yeah, here I have an NP arange 1 to 9. Again, similar to range function, arange method also starts from the first parameter and it goes until the last parameter, but the last parameter is exclusive. So what will happen here? it will generate numbers from 1 to 8. Its start value is 1, and 9 is exclusive, and the default is increment is by 1. So it will generate 1, 2, 3, 4, 5, 6, 7, 8, as we see here. Okay. Here we have another one. Start from 12, increase every time by 2, go on to 22. So 22 is exclusive, so it will generate numbers 12, 14, 16, 18, and 20. Okay. With this. Here we have another range. Start with 1, go up to 2, but each time increment by 0.1. What is the result? 1.0, 1.1, 1.2, blah, 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 up to 1.9. Why? Because 2 is exclusive. Okay. Or here we have another one. Start with from 3.2. Every time decrease by 0.2 up to 1.6, which is exclusive. So what will be the numbers that will be generated? 3.2, decrease by 0.2, or add minus 0.2. After 3.2, we will get 3, 2.8, 2.6, 2.4, blah, blah, up to 1.8. And the next value would be 1.6, but the second parameter is 1.6, which is exclusive. I hope this is understood. So in a range, we can either have integer numbers increasing or decreasing. We could have here a negative number, 22 to 12 by minus 2, for example, similar to range function. But in addition to or a superiority of a range NumPy method to range function is that we can have here float increments or decrements. Next, we have reshape. If you want, here until now, we have seen some examples which creates just flat arrays. But I want to create not a flat array, but a matrix, a two-dimensional array. What should I do? Then in this case, I will be using reshape method. Let's see here, where is my reshape? Okay, here I have NP arrange 15. Similar to range function, what arrange 15 does, if there is only one parameter, the start value is 0. So arrange 15 will create numbers from 0 to 14, okay? As we see here, 0 to 14. But I want to reshape those 15 numbers on 3 rows and 5 columns. I will create a matrix, a two-dimensional matrix or two-dimensional array, which contains 3 rows and 5 columns. So after creating an array of 15 elements with numbers from 0 to 14 here, what I do, I take this created array and reshape it to have 3 rows and 5 columns. Let's put here not 15 but 14. So what are how many numbers are there here? From 0 to 13, only 14 numbers exist. But here I'm trying to create a two-dimensional array or a matrix of 3 rows and 5 columns, which requires 15 elements. But here I only have 14 elements. So what will happen? It will give me an error because the number of elements here is not sufficient to reshape by 3 rows and 5 columns. Okay, so the number of elements here, if let's put here 19 more elements than necessary, I will again get an error because here I have 0 to 18 numbers, 0 to 18, 19 numbers, but I am trying to reshape to a two-dimensional array of 3 rows and 5 columns, which requires 15 values. So the number of values here and in the reshape doesn't fit each other. So I get an error message. So what I will do, I will again make this 15. So this will create from 0 to 14, 15 numbers. And when I reshape them, I will get something which is correct. Let's go and check our 15. Where is the 15 range reshape matrix 2D? Yeah, here. This is where is our output. So if I have an array, a flat array, a one-dimensional array, in order to reshape it to a two-dimensional matrix, I will do that. I will show you one other example. I will not write the program here, but I will show it elsewhere. Assume that I have a list, LST equal list range 1, 20, 21. What will this do? This will create a list which contains numbers from 1 to 20. Therefore, there will be 20 numbers. Let's put here a comment 1, 2, 3, 4, up to 20. Okay, with this line. From this one, assume that I'm creating an array. AR is equal to NumPy array using this list. What it will do, it will create from this list. Normally, when we create a list and print it, it will be printing something like this. After this, a comma, and of course it will not be 3 dots, but there will be real numbers, but I'm just abbreviating it. And in the exams, if you see something with 3 dots, please take it literally. It will be something wrong. You shouldn't write any 3 dots in a program. Okay, this is just to show you. Now, what happens here by creating an NP array? What I will get? I will get this. Okay. There will be no dots. Okay. Up to 20. Now, I want to reshape this array to a matrix of, let's say, 4 rows and 5 columns. Since there are 20 numbers, I can create a matrix of 4 by 5. Okay, 4 rows and 5 columns. What I would do, I would say my matrix MT is equal to, I will take this array, this NumPy array, and reshape it. And as parameters, first of all, I will put the number of rows and then the number of columns. So let's take these statements here from here, Control C. I will go here. I will add to the end. Let's put this somewhere here. Okay, now I have this. Let's print this empty. Here I have a list of 20 numbers, this list. I create a NumPy array using this list, LST, to get a NumPy array, and then I'm reshaping that, and I'm printing that. Let's run this. Here I see my matrix, okay? So the values, the first 5 values will make the first row, the next 5 values will make the second row, next 5 values will make the third row, and the last 5 values will make the last row. So reshape is used to create a multi-dimensional array from a flat array. Now, instead of having 4 by 5, what I will do, I will have 2, 2, 5. I have a 3-dimensional array. 2 pieces, each having 2 rows and 5 columns. 2 rows and 5 columns will make a matrix of 10 elements, and twice that in two places we will have the same thing. So this will have 2 multiplied by 2 multiplied by 5. a total of 20 elements. If I print this, I will see this. This is the first matrix. Okay, here we have the first matrix, and here we have the second matrix. All together, it makes a 3-dimensional array. Lucky for you, I will not ask in exams, in second quiz and in the final exam, 3-dimensional arrays, but I will ask 2-dimensional arrays. Okay, I will ask matrices, but I will not ask any questions about 3-dimensional arrays. In Python, it is possible to create 3-dimensional, 4-dimensional, 5th-dimensional. Let's put here, for example, not 21, but 41. And let's put here, or 2, 2, 2, 2, 8, let's say 17. And let's put here 2 and 2. Let's run this. As you see, this is 1 dimension, 2 dimension. Together, this is the 3rd dimension. And there is the same thing again, a 3-dimensional thing here, another 3-dimensional thing here. All together, this is a 4-dimensional data. But as I said, I will not ask in exams more than 2 dimensions. Let's say, for example, this is 4 by 4, which is a matrix of 16 elements. Here we have that. Okay. So in NumPy arrays, you can create 2-dimensional, 3-dimensional, 4-dimensional, 5-dimensional. There is no limit. Maybe there is some limit, but anyway, you can create a multi-dimensional data structure. Let's continue with our methods. Frequently in mathematics, we may need to create an array or a matrix which contains only zeros. Okay, let's go here. I have somewhere at the beginning of my program, I have zeros. Let's run this program again. Let's go to top. Here I have NP zeros, as you see here, but there is one important thing. You have to understand that. In arrange, I just write here the number of rows and columns as 2 parameters. As we have seen here, arrange 1,9 or 12, blah blah. This is the start value. This is the end value, exclusive. And if there is no 3rd parameter, the default increment is 1. Or we can put a default. We can put some other increment or decrement. And here we have just some parameters. But when I use zeros to create an array or a matrix which only contains zeros, as you see here, there are only zeros, I have to put the dimensions in a tuple. As we know, a tuple starts with parenthesis and ends with a parenthesis. And if there is only one element in a tuple, that element is followed by a comma. So here I have a tuple. Okay, here I have another tuple. If I write just 2 and 3 without any tuple, these 2 and 3 are just parameters to zeros. I will probably get an error. Yeah, I've got an error because zeros requires a tuple parameter. So I have to put this 2 and 3 in a tuple. Now I have just one parameter. This zeros method has only one parameter. It is a tuple, but the tuple contains 2 elements. Okay, but anyway, zeros method requires a tuple. Similarly, we have a once method which also requires a tuple. What is the result of zeros and ones? Zeros just produces a single dimensional, 2-dimensional, or 3-dimensional, or whatever n-dimensional array which only contains zeros, and ones creates arrays which only contains ones. How did I get 4s? I multiplied by 4. I will come to this later on in a few minutes time. So when you need an array containing zeros, you can use zeros. If you need an array containing ones, a single dimensional or multi-dimensional, let's put here one more. Control C. What I will just write A0, A0, and just let's put here 7, comma. This is a tuple which only contains one element. Therefore, this will be a one-dimensional, a single-dimensional array which only contains ones. Let's go to top. Here I have my NumPy array which contains only ones. It's a single-dimensional NumPy array which contains 7 elements. Okay, and this is the way how to create an array, a single array which contains all ones. If I want to have all, for example, trees, what I do, I create an array which contains ones and I multiply each element by 3. Multiplication or addition is just adds to every element in a NumPy array. But if you have a list, for example, okay, when you add 2 lists, what happens? It appends the elements of one list to the end of the other list, okay? So here, for example, LS3 is just addition of LST1 and LST2. What it does, it appends the elements of LST2 to the end of LST1 and creates a new list. This doesn't change LST1. LST1 plus LST2 just creates a new list, which is just made up by concatenating all the elements of LST2 to the end of LST1 in a new list. But in NumPy arrays, when we do plus, it doesn't create a new array, it creates a new array, but it doesn't create a new array which contains that much elements. Instead, let's put here, assume that there's also 8 here, comma 8, comma 8. What happens? The first elements are added, okay? 1 and 5 is added. Here, this contains 1 to 4. This contains 5 to 8, okay? LST1 is converted to A1. Therefore, here we have 1 to 4. Here we have 5 to 8. What does the plus operator? It adds element by element. So 1 plus 5, 6. 2 plus 6, 8. 3 plus 7 is 10. 4 plus 8 is 12. So we get this list, sorry, we get this NumPy array when we add. So the addition of lists and the addition of arrays are completely 2 different things. If instead of adding 2 arrays, if I add an array and a number, assume that I have A4 is equal to A1 plus 4. What will happen? Let's write here our list only contains 1, 2, 3, and 4. Okay, this is our list. Sorry, this is our array 1, 2, 3, 4, which only contains these values. If I add 4, what will happen? It will create an array in which every element of A1 is added 4. Okay, so 1 plus 4, 5, 2 plus 4, 6, 3 plus 4, 7, 4 plus 4, 8. Okay, so addition just changes every element. It doesn't add new elements. It modifies the elements. It creates a new list. Sorry, it creates a new array. It creates a new NumPy array in which every element of A1 is increased by 4. Okay, we get this. So the addition, subtraction, multiplication, division, or floor division operators can be used between either 2 arrays. Instead of plus, I could write here multiply. In that case, 1 plus 5, well, sorry, 1 times 5 is 5. Okay, we will get 5. 2 times 6 is 12. 3 times 7 is 21. 4 times 8 is 32. Okay, when I multiply them, it will be something like that. Or if I have minus here, 1 minus 5 is minus 4. Okay, 2 minus 6 is -4 again, 3 minus 7 is -4 again, and 4 minus 8 is -4 again. For example, I can subtract two arrays, in which case every element is subtracted from the other array. Okay, the operation is performed element by element. And similarly, if I have here multiplication, then 1 times 4 is 4. 2 times 4 is 8. 3 times 4 is 12, and 4 times 4 is 16. Okay, when you do an arithmetic operation between an array and a number, then each element of the array is performed that operation, either addition, subtraction, multiplication, division, or floor division. It doesn't matter. It performs the operation element by element. Is this clear? You have to understand this very clearly.
Yes, it's clear.
Okay, thank you. This facilitates many operations on arrays. Okay. Now let's continue
Professor?
with. Yes.
If there are like two arrays and you want to subtract one from the other, for example, but the dimensions are different. I mean, like one has more values.
The dimensions must be same. Okay. In order to add, subtract, multiply, divide, or floor divide two arrays, the dimensions must be identical.
Okay.
If the dimensions are not equal, then you will get an error.
Thank you.
Okay. So when you want to, for example, let's do it here in our program. Let's put here one array A is equal to np dot arrange 1, 5, which will produce values from 1 to 4. Okay, and B is equal to np dot range from 10 to 60, increased by 10. So here I have values 1, 2, 3, 4, 1, 2, 3, and 4. But in the next one, sorry, I have values 10, 20, 30, 40, and 50, up to 60. Each time it is increased by 10. If I try to do C is equal to A plus B, and let's try to print C. Let's see what will happen. I get an error message here. Okay, it is red. It says operands could not be broadcast together with shapes 4 and 5. You see that one has 4 elements, the other has 5 elements. You see the error message below. So in order to perform an arithmetic operation between two NumPy arrays, or between a NumPy array and a number, between NumPy array and a number, there is no problem. It performs that. But if it performs an arithmetic operation between two arrays of any size, any dimension, either 1-dimensional, 2-dimensional, 3-dimensional, it doesn't matter, then the sizes must be identical. For example, let's assume that this is 6. Now, if I just run this, it will be fine, okay? Or I can put here multiplication, then the multiplication will be done, okay? Instead of having here, I have 4 elements. Let's make this, for example, 12 elements up to 13 and up to 130. There are 12 elements. And what I will be doing, I will be reshaping them. Reshape. There are 12 elements. Therefore, I can make it 3 rows and 4 columns. Okay. And what I will do, I will just take this, Control C, copy this, and put here. Let's hear what I will do. I will print A and B, print A and print B, and print C. We see that this is, let's put here before that one. After the last equal signs, okay. Here, this is A, okay. From 1 to 12, reshaped to have 3 rows and 4 columns. So I have this matrix, and here I have numbers from 10 to 120, and I'm reshaping them again to have 3 rows and 4 columns. I have this, and here I multiply each individually. 1 times 10 is 10. For example, 11 times 110 is this one, etc. Now assume that I have here not 3 rows by 4 columns, but 4 rows and 3 columns. Both have 12 elements, but the shapes are not same. This has 3 rows, 4 columns, and the other one has 4 rows, 3 columns. When I will try to run it, then it will give an error because the total number of elements in A and B are equal, but their shapes are not same. Okay. So in order to perform multiplication, addition, subtraction, division, or floor division between 2 arrays, their shapes must be identical. Here again, I will get an error message because their shapes are not the same. This is 3 by 4 and the other one is 4 by 3. The shapes doesn't match each other, so there is an error message here. I hope this is well understood. Let's put this 3 by 4 and let's make this B minus A. Let's run this again, and this time there will be no problem. Yes, any questions?
Yes, can we multiply like matrices?
Yep, I will come to that. I will explain it in a few minutes.
Okay.
So here we have seen zeros. It creates either a single array or multidimensional array of zeros. Ones creates a single dimensional or multidimensional array of ones, only containing ones. In mathematics and in engineering, in scientific computation, frequently we need identity matrices. Okay, an identity matrix is a square matrix in which has only ones in the main diagonal and zeros elsewhere. So let's go and check our program. Let's run this program again. Here we have identity. Okay, identity or I. There are 2 functions, two NumPy methods which creates identity matrix or unit matrix. Here, let's go and see them on top. Where are they? Here they are. Created with NP with I. Okay, we have this 1 on the main diagonal and 0 elsewhere. And identity is also does the same thing. Identity and I matrices, the identity method and I method exactly produce the same result. So one is alias of the other one. Both are same. I and identity just requires one number, 4 or 5. Let's put here, for example, 3. I will change this to 3. So it will generate a 3 by 3 identity matrix or unit matrix. Let's go to top. Here I have 3 by 3 because my parameter is 3. The I and identity methods always creates a 2-dimensional array, or in other words, a matrix which only contains ones in the main diagonal and zeros in all other elements. Okay? As you see here, there are ones in the main diagonal and 0 elsewhere. When you multiply a unit matrix or identity matrix with a normal matrix, the result will be the matrix itself. Okay, you know that probably from high school. So frequently the identity can be used. Let's continue with our things. Okay, now we come to transpose and matrix multiplication. If you want to get the transpose of a matrix, you just use the transpose method. It creates a new matrix, returns a new matrix that is transpose of the given matrix. Okay, This gives us a new matrix which performs the matrix multiplication. Let's see how we do that. Here, let's go array operations, matrix operations. Okay. In the matrix operations part, we have here a transpose. I've just declared again an array which has values from 1 to 12, and I reshaped them to have a 3 rows by 4 columns matrix. When we print this, let's see the output, array operations, matrix operations. Okay, here is my matrix. Okay, M1. This is M1. When I take, if I want to take the transpose of that, what I do, I say M1 dot transpose. This gives me a new matrix, which is the transpose of M1. And I store this into M1T, T for transpose. When I print this M1T, I see that the rows becomes columns. 1, 2, 3, 4 is the row 1, but 1, 2, 3, 4 are in the column. 5, 6, 7, 8, second row, it becomes second column, or the first column, which is 1, 5, 9, becomes a row. The second column, 2, 6, 10, becomes the second row, etc. So in order to get a transpose of a matrix, we just use the transpose method with the matrix itself. In order to multiply two matrices, we use the dot method. Here the dot method is used for matrix multiplication. How do we use it? Here I have a matrix 3 by 4. Here I have another matrix which has 4 rows by 2 columns. In order to multiply two matrices, as you know, the number of rows in the second matrix must be equal to the number of columns in the first matrix. So the number of columns of the first matrix must be equal to the number of rows in the second matrix. So if this condition is satisfied, then you can do this. M1 dot, this is the first matrix, multiplied by the second matrix. We write the second matrix as the parameter of the dot method. M1 dot M2 will create a 3 by 2 matrix. As you know, the result of a matrix multiplication contains or the number of rows of the matrix multiplication is equal to the number of rows of the first matrix, and number of the columns is equal to the number of columns of the second matrix. The result of this multiplication between M1 and M2 will have 3 rows and 2 columns. And as we see here, this says 3 rows, 4 columns. This says 4 rows, 2 columns. The multiplication contains equal to the number of rows of the multiplication is equal to the number of rows of the first one, and number of columns is equal to the number of columns of the second matrix. Therefore, it will have 3 rows, and it will have 2 columns, as we see here. When we print M3, it is this one. Sorry. Any questions about matrix transpose and matrix multiplication? As you see, it is quite easy with NumPy arrays. What else do I have here? I have tile and repeat methods. I'll explain these to you. I've explained the addition, subtraction, multiplication, division, and floor division between two NumPy arrays. The sizes must be equal, and it will create a new array in which every element one by one is added to the other array's element or subtracted from the other array or multiplied with the other array. Okay, so the arithmetic operations just performs element by element addition, subtraction, multiplication, division, and floor division. So A multiplied by B will not perform matrix multiplication. Okay, you have to be careful about that. Multiplication operator, the asterisk operator, does not perform matrix multiplication. The matrix multiplication is performed with the dot method. You have to be careful about that. Any questions so far about NumPy arrays? Is everything understood well?
Yes, teacher.
Thank you. What I will do, I will show you two more comments, two more methods, tile method and repeat method. Here we have NP arrange 1, 5. What it does, it creates an array which contains 1, 2, 3, 4. It starts with 1 and 5 is exclusive. Therefore, NP arrange just creates an array containing 1, 2, 3, 4. When we want to, if we want to repeat those elements, for example, twice, what do? We use the tile method. np.tile will require two parameters. The first parameter is an array. The second parameter is how many times those elements will be repeated. So when I have an array here and a number as the second parameter, what it does, it will repeat each element of this first parameter the number of times equal here. Since it is 2, 1, 2, 3, 4, and 1, 2, 3, 4 are repeated. Okay, this is the tile method. It requires an array and a number. There's another method which is repeat. Here I have np.repeat and the parameters are same. np arrange 1 to 5 and 2. What is the difference? Again here, this will create an array consisting of 1, 2, 3, and 4. But this time in the repeat method of NumPy library, what it does, it repeats the elements just one by one. I mean, 1 is repeated twice, 2 is repeated twice, 3 is repeated twice, and 4 is repeated twice. So there's a major difference between tile and repeat. Both repeats, but one repeats all of the list of all of the array again. In the other one, elements are repeated successively. Okay, this is the main difference between tile and repeat. Is this understood? Here I put those examples to stress the differences between tile and repeat. Now I will show you several questions. These I will again share these programs in LMS. I will just after the lecture I will upload these programs, the NumPy A11 NumPy 1 and A11 NumPy 2. NumPy 1 just contains the things that I've explained to you. Let's see here some examples about tile and repeat. Here we have an array which has 1 to 4, the value is 1 to 4. And when we repeat it twice, we will just see those. Where is the tile? Yeah, here is the tile. This is our A. B is NP tile A, 2. So every element is repeated twice. Okay. So here is my B. Here I have C, NP tile, NP arrange 1, 4. Therefore, this will create values 1, 2, and 3, which is repeated 4 times. 1, 2, 3, repeated 4 times. 1, 2, 3, 1, 2, 3, and 1, 2, 3. Okay. So either I can get one array and write a number, or I can directly create the array as the parameter and write a number here to repeat the elements. Assume that here I have, okay, here I have np tile, blah, blah, something. Here again, I have my tile stuff. And then I'm getting, for example, this kind of stuff, but I'm reshaping them. Here what I have NP range 15, which will create an array consisting of numbers 1, 2, 3, 4. Repeat those 4 times. 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. But reshape them 4 by 4. So I get this as result. Okay. Is this clear?
Yes, it's like multiply.
Yeah. Here it is repeated, not multiplied. When I multiply 1 multiplied by 4 will be 4, 2 multiplied by 4 will be 8, 12, and 16. But it's not multiplication, it is repetition. Okay. So the elements are repeated. Whole array is repeated again and again. 1 to 3 is repeated 4 times. So 1 to 3, 1 to 3, 1 to 3, 1 to 3 is repeated 4 times. Here 1 to 4 is repeated 4 times. 1 to 3, 4, 1 to 3, 4, 1 to 3, 4, 1 to 3, 4. But I'm reshaping them 4 by 4 to get this. If I repeat, for example, have 2 by 8, okay, what I would get, let's see the tile stuff here. I will get this. Okay, there are 4 elements here. Those 4 elements are repeated 4 times to have 16 elements after the tile. And those 16 elements, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, are reshaped on 2 rows and 8 columns. Therefore, I get this. Or if I have, for example, 8 rows and 2 columns, then what I would get, let's go to tile, I will get this. 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, and 1, 2, 3, 4. 1, 2, 3, 4 generated here is repeated 4 times, and it's reshaped to have a matrix of 8 rows and 2 columns. So 1, 2, and 3, 4, and 1, 2, and 3, 4, etc. There are 8 columns and 2 rows. Sorry, 8 rows and 2 columns here.
Sorry, teacher.
Okay, let's return it back to 4 by 4. Here I have repeat 4.8 is repeated 3 times. In repeat and tile, here what I will do, I will just do one more example about tile. Let's put here x is equal to np dot tile. Here I have I have a list, an array and repeat it. I will just have here 7 and 4. And let's print x. Let's go to our tile part. Here you see the result, okay? Now it creates, tile creates an array in which the first parameter is repeated. If the first parameter is an array, the elements of those array are repeated. If the first parameter is a number, then it creates an array in which the number is repeated. So 7 is repeated 4 times. So I get this, okay? Is this clear? So the tile method can get either a number and a second number in which the first one is repeated. Let's put here 7.2. My number is a float number. Here is my result. I have an array in which the value 7.2 is repeated 4 times. Okay, I get this array. So, but in the second one here, the first parameter is an array which contains 1 to 4, and it is repeated twice. 1 to 4, 1 to 4 is repeated twice. So the tile method and the repeat method can be used the same way. Here repeat 4.8 by 3, it will create this one, 4.8, 4.8, 4.8. If we have only a number and an integer, Repeat and tile produce the same result. 7.2 is repeated 4 times, 4.8 is repeated 3 times. Here, either to use tile or repeat doesn't matter, but if the first parameter in tile or in the repeat is an array, then it matters. In one, it just repeats 1, 2, 3, 4, 1, 2, 3, 4. In the other one, it is 1, 1, 2, 2, 3, 3, 4, 4. Okay. This is what repeat does, and this is what tile does. In both, the input is an array which contains 1, 2, 3, 4. 1, 2, 3, 4 tile 2 will create this. 1, 2, 3, 4 repeat 2 will create that one. Now let's see some examples, some example questions. Create an array containing 2-digit positive numbers divisible by 10. Okay. So what I do, I write NP arrange. As I said before, arrange is similar to range method, but it is used to create an NP array. 2-digit positive numbers start from 10, goes until 100 exclusive. And since I want divisible by 10, it has to increase by 10, 10, 20, 30, etc. up to 90. So what I write the result, the answer of this question. If I say in exam, write a Python statement or Python program which creates an array containing 2-digit positive numbers which are divisible by 10, the answer is this one. Okay, you will have to write only one line. What is another solution? I will just write another solution here. Here I will have, for example, a list. LST is equal to list range 10 to 100 increased by 10. This creates a list, okay? And after that, what I can do, I may have my array is equal to NumPy.array, which converts this list to an array, okay? Here I create a list, an array, NumPy array method takes a list and creates an array. So what I can do, I can take this from here and put here. Both the result is same in both. Let's print this ARR. I will just change the name of this one to ARR. And let's run this program. Let's go to top. Here you see that the result is same. Here I directly used the arrange method of the NP. Here I used array, which converts a list to an array. The result is same. Which one is more simple? Naturally, this is more simple. Okay. Here it is indirect. Indirectly, I create a list and then convert that list to an array. Here I just create immediately an array by using the arrange method. Is this understood? But yes. In the exam, if you write this, I will accept it as true, as correct. But of course, I would prefer that one, that solution. Second exercise. Create a 4x4 array or matrix containing numbers 10, 20, 30 up to 160. Why 160? Since there are 4x4, there are 16 elements. If I start from 10, my last value will be 160. So what I do, I create here with arrange 10 to 170 increased by 10. Since the second parameter is exclusive, this will create values from 10 to 160. And I want them to be in a 4x4 array. So what I do, I use reshape 4, 4. When I run this, I get that result. Okay. Is this understood?
Yes.
Next, create a 4x4 array containing numbers 16, 15, 14 up to 1. Okay, it is easy. Now, since if you understand this, it is quite easy. My initial value is 16. Every time it will decrease by 1 up to 1. So what I write, start with 16. Every time add -1, or other words, subtract 1, and go until 0. Since the second parameter is exclusive, I have to put here 0. If I put here 1, it will go from 16 to 2. 1 will be exclusive. Therefore, I put here 0. Okay. And again, reshape 4x4. So here I have my output. Create a 4x4 array containing numbers 1, 2, 3, 4 vertically. I want to have 1, 2, 3, 4 in the first column, 5, 6, 7, 8 in the second column, blah, blah. How do I do this? It is easy. Where it is here, what I do, I create an array, a two-dimensional array from 1 to 16 using 1 to 17. Of course, 17 is exclusive. Reshape 4x4. So the first row will have 1, 2, 3, 4. Second row 4, 5, 6, 7. So 5, 6, 7, 8, etc. When I take the transpose, 1, 2, 3, 4, which was in the first row, will be the first column. Okay. Here it is quite interesting. If I want to have them vertically, then what I do, I create the matrix normally 1, 2, 3, 4 on the first row, 5, 6, 7, 8 on the second row, etc. And when I take the transpose, the row becomes column and the columns becomes row. So I get this result. Okay, let's run it again. Let's look here. Here it is, array containing numbers 1, 2, 3, 4, but they are vertically placed. So I just create a matrix and then take the transpose, then I have this result. I have this is clear. And as you see, this is clever. This is a clever solution. You can try to do this in another way, in some other ways, but it will be several statements, not only one statement, but you can do this in several statements. This is how to do it easily. Okay. Create an n by n array with ones in the first row, second, twos in the second row, and so on. So I want to have something like this. Okay. A 6 by, for example, if n is 6, I will have a 6 by 6. This n by n. Be careful. Read this question carefully. Create n by n array with ones in the first row, second twos on the second row, etc. I have here my variable n equal to 6, for example. What I do, I repeat the values. 1, 1, 1, 1, 2, 2, 2, 2, 3, 3, 3, etc. are repeated. How do I do this? Here I have my NPA range 1, n plus 1. Since the second parameter is exclusive, in order to get values from 1 to n, I use this. So this creates an array which contains 1, 2, 3, 4, 5 up to n. N is inclusive. N plus 1 is exclusive. And then repeat this n times. So what I get this. 1 is repeated n times, 2 is repeated n times, or since the n is 6, they are repeated 6 times, etc. I have this, okay, this one. This x is here, as I highlighted them. Now, after getting this, what I do, I reshape it n by n. I can write everything in one line. NP, repeat. This is 1 to n, and n times, which creates this 1, 1, 1, 1, 2, 2, 2, 2, 3, 3, 3, 3, etc. And then reshape them by n. Here I have, first of all, created just a single dimensional array and then reshaped it to get this one. Here I performed everything on one line. Repeat 1 to 6 6 times, 1 to 6 repeated 6 times, so there are 6 1s, 6 2, 6 3, 6 4, 6 5s, and 6 6s, and then reshape them. Then I get 1 1 1 1 on the first row, 2s on the second row, etc. Now I have a similar thing, but this time I want to have 1 2 3 4 5, and ones are in the columns, 2s are in the second column, 3s are on the third column, etc. Here, read the question carefully. Create n by n array with 1s in the first row, 2s on the second row, etc. Let's put here row. But this time, create an n by n array with 1s in the first column, 2s on the second column, and so on. So the difference between these two is here is that I have 1s on the first row, 2s on the second row, 3s on the third row, etc. But here I have 1 2 3 4 1s on the first column, 2s on the second column. Just look to the column, okay? 3s on the third column, etc. So what is the difference? Here I use the repeat, and here I use tile. Why do I use tile? When I use tile, it will just repeat the elements. All elements are repeated again. 1 to 6 is repeated, 1 to 6, 1 to 6, etc. This is the result of tile, okay? Here I have my array 1 to 6, and 6, it is repeated 6 times. The tile will produce this result, okay? The first one. This one is the result of tile. To the contrary, when I use repeat, this is the result of the repeat, okay? As I explained just a few minutes ago, when you use repeat, every element is repeated again and again, and then it continues with the next element repeated, etc. When I use tile, all elements are taken and they are repeated again. Okay, 1 to 6 is taken, and then it is 1 to 6 is repeated again. So when I make a matrix from this will be result 1 to 6 and 1 to 6 repeated, and the second row, third row, etc. So what I do, I use tile method to create all elements and then reshape them. Here I use repeat method to create all elements of the matrix and reshape them. So when I use repeat, I get this result, and when I use tile, I get this result. I hope this is understood. So your questions may contain things similar to these, okay? If you understand this, these are probably almost the most complicated questions that I may ask.
Professor?
Yes.
Another method, couldn't we take the first one and do the transpose?
Oh, yeah, you are right. You can make with repeat and then put here dot transpose. You mean this? That's correct. That's also possible. It will make the statement longer, but it is possible. I didn't think about that, but yeah, that's true. So what I will do, I will just copy this here. Let's put here W, and let's put here W. Instead of tile, let's use repeat, and at the end dot transpose to take the transpose of it. Let's run this. Where it is? Here it is. Okay. The first one is here. The second one is Z, and the third one is W. Okay. Yeah, you are right. You can do it with transpose as well. Any questions? Did you understand what your friend informed us?
Yes.
That's good, because using this tile, repeat, arrange, shape, etc., transpose, you can do lots of interesting things. Very enjoyable things can be done with those.
And is there a limit for the dot function? Is there a limit?
Limit of using this cascaded methods?
Functions.
You mean? Yeah.
Is there a limit bunch or more functions?
Limit of what? Limit of cascading methods like this, you mean?
Yes. We use repeat, then reshape, then transpose, then how many functions we can
Yeah,
use?
you can. I don't know the limit. For example, if you transpose again, okay, let's transpose and transpose again, what will happen? It will be the original one, okay? Here, for example, I transpose and transpose again, and I get this. So here, there is no limit. I don't know if there's any limit.
Okay.
Okay. Any other question? Create n by n array with n's on the first row of n minus 1s. Okay, now the question is slightly different. I want to have, if it is 4, for example, 4s on the first row, 3s on the second. Just read the question carefully. Create n by n array with n on the first row, n minus 1 on the second row, etc. So what I want to have, 4 here, 3 on the second row, 2 here and 1 here. How will I have to do that? I just put here, fix this statement. I didn't solve it. Just now I'm asking you, what shall I change here to have that? 4, 3, 2 and 1 on the rows. If it is 4, of course. Or in other words, n's on the first row, n minus 1s on the second row, etc. What I have to change here? I have to produce 4, 3, 2, 1. Okay. So I have to start with 4, go until 0 by minus 1. So what will do? What will this produce? This np.arrange 4 to 0 minus 1. It will create 4, 3, 2, 1. Repeat this n times. Therefore, there will be 4 times 4, 4 times 3, 4 times 2, and 4 times 1 with this repeat. And reshape it, and then we will get where it is here. Okay. N by n array with n's on the first row, n is 4, 4's on the first row, 3's on the second, etc. Now I want to have n by n array with n's in the first column. The first column will be n's, n minus 1 is on the second column. One way is just transpose this. If we transpose this, we will get the result. But instead of that, what I will do, I will use tile method. Just copy this, put it here. Of course, not 4. It's my mistake. Sorry. Start from n. This is the correct way. If n is not 5, 4, but 5, this will still work. Okay. So in the questions, when I give you examples, please don't use the numbers in the examples, okay, or the strings or whatever in the examples. If the question says n by n, and if you put here 4, it will not be correct. Or if you put here 4 and 4 and 4, if I give an example with 4, it will not, the answer will not be correct, because the question says create n by n array containing n's in the first row, n minus 1s in the second row, etc. But in the question, I may give an example using the value 4. But if you put here 4 instead of n, your answer will not be correct, because the question says create n by n array with n's in the first row, etc. So the answer must be conformant with the question, should solve the question, will be answer of the question. It shouldn't be the answer of the example. Example is just an example, okay? So please, in the exams, when you see an example, don't write a Python program or Python statement which only solves the example. You should solve the generic question, okay? So here, putting force here will not be a correct answer. Here, I will, instead of repeating, we are tiling. So this will create 4, 3, 2, 1. When we tile them, it will be 4, 3, 2, 1, 4, 3, 2, 1, 4, 3, 2, 1, 4, 3, 2, 1. And when we will reshape it, we will get this answer. N's are on the first column. N is in the first column. N minus 1s are on the second column. Let's put here the, sorry. And so on. And second row and so on. So when I use tile, it will just repeat 4, 3, 2, 1, 4, 3, 2, 1, 4, 3, 2, 1, 4, 3, 2, 1, etc. n times. And then when I reshape, I will get this. Of course, as your friend just mentioned just a few minutes ago about transpose, what I can do, instead of using tile, I can have here repeat, but at the end, by just putting transpose, I can get the same answer. We don't need to fix, we already fixed it. We can delete this. Let's run this. And here we see that the second example is also, the second solution is also correct. I used repeat, but then I just transposed. Similarly, what I can do, I can use here tile and then dot transpose to have the same result. Here, as you see, there are two solutions. Start with repeat or start with tile and then transpose. Create an array with ones on the border and 0 inside. I want to have this solution. How do I do that? Now you will learn a new thing. It is the slicing of NP arrays. Here, using NP ones 6,6, I just create, or let's put here n is equal to 6, and here I will just use n. Let's run this, the result is the same. Here I have my array that is created using ones. But what I want is to create an array and by an array with ones on the border and 0 inside. Okay. So here I first create an two-dimensional array which only contains ones everywhere. And then I want to change the inner part with zeros. What I do here, I use slicing. What I do here, the first one is for the rows. The second one is for the columns, okay? So for the rows, I have since the indexes start from 0, index 1 is the second row, okay? Index 1 is the second row. And here again, for column index, index 1 is the second column. It is this column, okay? The second column. What do we do here? -1 is the last row. Since in the slicing, like in slicing, the second value is exclusive. So start from the second row, okay? Second row. Don't go until the last one, go until the last one, but the last row is exclusive. So it goes up to last row -1. it will just take these rows, okay? It will not take the last row with 1 and -1. -1 is the last row, but the second value in the slicing is exclusive, so this doesn't take the last row. The 0 is the first row, 1 is the second row. Start from the second row, go to the end, except the last row. This is the slicing for the rows. And after comma, I have slicing for the columns. Again, 1 is the index of the second column. Start from the second column, and -1 is the index of the last column. But in the slicing, as I said before, the second one is exclusive. So when I put here -1, it means that the last column here is not included. So it will go up to the column before the last one. And in that area, just put all zeros. So here in the middle part here is set to 0 with this line on line 81. Okay, on line 81, we are just assigning zeros to this sliced area. This is the sliced area, okay, the middle part. And when I print X, I get this one. It is. I found this question from web today. Okay, I just did as research on the web about NumPy exercises. I found a quite nice site. Where it is, NumPy. This is not introduction. I will go here, NumPy array exercises. Oh, NumPy array exercises. If you just do a NumPy array exercises search, I think it was this one. I will just check it and tell you. No, it's not this one. It was a quite interesting. I found a nice site. I will try to find it out and share it in LMS. In here we have Python tutorial sites and exercises sites. I will put that site. I find a very nice site which contains very nice NumPy exercises. I will find it again and put it here. Currently, it doesn't contain that one. It contains NumPy exercises site, but it doesn't contain it is Python exercises. It doesn't contain yet NumPy exercises. I will find that site again. It contains very nice and interesting exercises, and this is one of the exercises that I found there. Okay, create an n by n array which contains ones at the border and zeros outside. Of course, instead of it n by n, it can be n by m. Okay, let's put here m is equal to 7. The solution will not be too different. I'll put here m. Okay, let's run this again. Here now I have 6 rows but 7 columns. Or let's make this 4 rows by 7 columns. It doesn't matter, 4 rows by 7 columns, and border is 1 and inside is 0. The only difference here is that instead of n, I put m while creating the two-dimensional array, which contains, it's not n by n but n by m, and then the slicing doesn't change at all. Start from the second column, excluding the last, sorry, start from the first row, second row, excluding the last row, do a row slicing here, and similarly do a column slicing here and put 0 to those values, which are the inner values. Okay, so this is the inner part, and using assignment, we assigned values to the inner part. Okay, so once you understand this, you can solve similar questions. Assume that I want to put not zeros but 2's inside. Okay, here now I have not ones but zeros but 2's inside. Or you can say, for example, create an empty array with 2's on the border and 1 inside. How do I do that? Any idea? 2 on the border and 1 inside. Any idea? It is quite easy. I create all ones. If I multiply them by 2, everything will be 2. But inside I want 1. Okay? 2 on the border, inside 1. 7 on the border, 4 inside. Okay? Create a matrix containing only ones. When I multiply by 7, all ones becomes 7. I get this. And then in the inner part, I put something else. Okay? So once you understand the idea, you can have many variations. And in the in my question bank, I will prepare several questions with different values on the border and different values inside. Once you understand this idea, you can just do it quickly. One more variation of that, I will put here 7 and 7. I will show you one more thing. Just I will put here 2. What does it mean? Start from the second row and each time go 2 rows forward. Don't take every row, but just take row 1, 3, 5, etc. You see this? It jumps 2 rows at a time. Here it is 4, go 2 rows below, 2 rows below. And here for the columns also I advance 2 by 2. After column 2, go to column 4, column 6, etc. Let's remove one of this. I just moved 2 rows at a time, but each column, and the result is this one. I have the inner values of row 2, inner values of row 4, inner values of row 6. Here I increased the row indexes by 2, but I didn't increase the column indexes by 2. It is just normal increase. So here I have this result. Okay. So by changing the row increments and column increments, you can have many different variations. Okay. So according to that, I can design lots of different questions, but the idea is just to set these things correctly. Once you understand the question perfectly, then by using the ones, you can create a matrix containing all the same values, whatever it is set here, and then you can change the elements with one statement, some of the elements with one statement, like here. Here I set, I go back to original. For each row, for each odd row, row 0 is even, row 1 is odd, row 3 is odd, row 5 is odd. So in order to get odd rows, what I can do, I can put here, if I just remove this, 1, nothing, and 2 will get all odd numbered rows. Okay, and 1 and nothing will be odd, all row, this all odd numbered columns. Here the question would be, store some value to all odd numbered row and column elements. Okay, when I do this, here you see that this is odd numbered column. So row, this is odd numbered column. Okay, odd numbered column. Columns, row 0 row 1, odd numbered row. Row 2, even numbered. Row 3, row 5. And here, this is column 0, column 1, column 3, column 5. What I did here, I filled all two-dimensional array with some number, and for all odd numbered rows and columns, odd numbered rows, odd numbered columns, I stored, for example, 4. Well, let's put here 0, and let's remove this 7. So create a matrix containing ones, but all odd numbered rows and odd numbered columns contain 0. This is the result. Okay, this is the solution. Here 1, nothing, 2 takes all the odd numbered rows, 1, nothing, and 2 takes all odd numbered columns, and we put 0 there. In order to get even numbered rows and columns, what do? We just remove this 1, or we just put 0. This will just take all even numbered rows and even numbered columns. Let's run this. This is even numbered row. This is even numbered column 0, column 0, column 2, column 4, column 6. So we get this, okay? If you want to have a chessboard with the first row's first column element equal to 1, what I would do, I would have here 8 by 8, and here 1, and let's run this. Let's see the result. Oh, I forget this. It is quite different. What I have to do is I will do this. Now it will be interesting. 0 and 1 here. Now I have my chessboard, okay? Assume that 1 is white and 0 is black, okay? Here I have my chessboard. 8 by 8. Examine these two and try to understand what I did. Of course, this will be probably the most difficult questions that could be asked. Create an 8 by 8 array which has on the first row 1 0 1 0, on the second row 0 1 0 1, etc. And this is repeated. And this is the result of this. I can solve this in another way. How can I do this? I will, in one statement, I can do that. Chess is equal to np dot tile. Tile what? I will get. I will just try one thing, and if it doesn't work, I will try one other thing. I will put 1 and 0. Okay, and this is repeated 32 times. And then reshape 8 by 8 and print chess. If this doesn't work, I will just do a small fix. Here it is. Oh, of course not true. NP. I will just fix this. Are you? Do you get bored? If this is boring, then I can finish it here. I'll just.
No, it's not boring.